Alright, for today's lesson we are going to be graphing tangent or tan of x. So we've talked about graphing sine, graphing cosine. Now we're going to talk about the third main trig function, which is tangent, and we'll see how this is related to the last two that we've talked about. So we're going to be using taking notes, but also looking at the unit circle that we've been working on since last week. So if you are following along at home, make sure that you have that out. Okay, so first thing we want to talk about is how to calculate tangent in reference to the unit circle. So we know for our standard triangle we use SOHCAHTOA, and so tangent is opposite over adjacent. So looking at a right triangle within the unit circle, we would have this angle theta. The hypotenuse, since it's a unit circle and the hypotenuse is just a radius of the circle, the hypotenuse is always 1. Okay, then this would be the opposite side, so we just think of that as the y value, right? If this here is kind of like 0, sorry. This would be 0, right? This is the x-axis, so whatever distance this is the y value. And then this is the adjacent side, which is just the x value. Okay, again, this would be like our y-axis. So any distance here is an x distance, okay? So if we look at sine and cosine, remember sine is just opposite over hypotenuse, which ends up just being y, right? It's just y over 1, so y. Then cosine theta is adjacent over hypotenuse, which would be x over 1, so that's just x. Okay, now looking at today's, right, the function we're focusing on now is tangent. Again, we know that that's opposite over adjacent from SOHCAHTOA up here. So if I'm looking at the opposite and the adjacent side, that's going to be y over x. But I can also think about this in terms of sine and cosine, right? Y here, well, that's just sine theta. So I could substitute that in here. And then x is just equal to cosine theta. So I could think about substituting that in here. In other words, I could think of tangent theta as sine divided by cosine. Okay, so this is just kind of a fun relationship between these three trig functions. You can talk about them in this way. Okay, for a specific angle, let's say we're talking about 30 degrees, which is pi over 6 radians. I know the x-coordinate here, or the cosine value, is rad 3 over 2, and the y-coordinate, or the sine value, is 1/2. So if I'm thinking about tangent, I know that I can just look at y over x, which is 1/2 over rad 3 over 2. Okay, and I'm dividing by a fraction, which means I'm going to flip the bottom and multiply. So I'm multiplying by the reciprocal here. Okay, the 2's cancel out, and I'm left with 1 over rad 3. Okay, so again, all I did, I took 1/2 here, and then instead of dividing, I multiplied by the reciprocal. Okay, so I have 1 over rad 3. And I want to rationalize the denominator, so I'll multiply top and bottom by rad 3. That gives me rad 3 over 3 as a final answer for tangent of 30. And if you look back in your notes, you'll see when we were dealing with special triangles, right, special right triangles, that's exactly what we found for a tangent of 30 as well. Okay, so what I asked students to do now was to use this kind of process to fill in their chart from 0 to 2 pi. So take some time, at least focus on these angles here. So 0, this is pi 6, and then in here you have pi over 4, pi thirds, and then pi over 2. So if you're at home, at least try to get these first 5 done on your own, and I'll show you the correct values here in just a moment. Okay, so here are the correct values for tangent theta. And you'll see sine and cosine are here as well. So if you've missed some other days and you haven't filled those in, make sure you get these table values as well. You'll notice there's a lot of patterns going on with tangent. We really only have 4 numbers, right? We have 0, 1, let me do this in white instead. We have 0, 1, root 3 over 3, and root 3, right? Those same 4 numbers repeat. We just have positive or negative. So here's another root 3, 1, root 3 over 3, 0, root 3 over 3, 1, root 3. Okay, so lots of repetition. Again, just changes with the positive and negative depending on the signs of sine and cosine. So here, for example, I have 1 positive and 1 negative. So when I divide, that's going to give me a negative. Okay, in the third quadrant here, these values, I have both negatives, so that's going to give me a positive when I divide, right? 2 negatives gives me a positive. So just some things to keep in mind there. You'll notice there's also these spaces with dashed lines. Okay, that's when it wants us to divide by 0, right? To find tangent right there, so tangent of pi over 2, for example, well, we would want to take 1 divided by 0, right? This is the, if we're doing tangent of pi over 2, that would equal this sign there, which is 1, and over the cosine, which is 0. So if I need to find this, right, 1 divided by 0, I can't do this, right? Dividing by 0 is a problem. So for those, that's why we have these lines. They basically just mean that it is undefined there. So this means undefined. You can write out just UND, or you can write the word undefined in those boxes. Okay, undefined, so it's not defined. We don't have a value there. And you'll see what that looks like on the graph. Okay, but notice that these ones are not a problem. So tangent of 0, for example, that is having me do 0 divided by 1. So different example here, if I'm looking at tangent of 0, that's just going to equal 0 divided by 1, and that's fine. That's just 0. Okay, I can have 0 in the numerator, just not in the denominator. Okay, so that's how the rest of the chart gets filled out. Okay, so then what I had students do was go on to Desmo, so that's where we are here. You want to click on this plus sign where it says add item and add in a table. Okay, when you do that, you get something that looks like this, and I wanted them to put in, for the x values, you're putting in the angle measures, so this is going to be 0, and then we would have pi divided by 6. The pi button is just going to be this button down here. Can you see the mouse? No. But it's down in the keyboard section. Down here there's a pi button, or you can just type in pi, and that will give you the pi button, or the pi symbol as well. Okay, so pi over 6, then I have pi divided by 4, pi divided by 3, and then pi divided by 2 was undefined, so I'm going to skip that one. The next one I would have would be 2 pi divided by 3, and I should put the 2 up here. There. Okay, so 2 pi thirds, and so on. So you would continue this all the way down to 2 pi, and put the corresponding tangent values. So at 0, tangent is 0. At pi over 6, we said that tangent is rad 3 divided by 3. Okay, make sure when you're inputting this on Desmos, after you put the rad 3, you move over to the side. See how the cursor is in a different location here versus here. Move outside of the radical before you do the divided by sign. Otherwise, what you'll end up with, if I was still here and I did divided by 3, it puts the whole thing in the radical, and we don't want that. So again, move over 1 and then divide by 3. Okay, at pi fourths, tangent is 1. At pi thirds, tangent is just square root of 3. And then at 2 pi thirds, tangent is negative square root of 3. Okay, so it kind of starts a new section down here. So if you're doing this at home for the first time, please go through all the way to 2 pi. It'll give you a better idea and better foundation of where this graph comes from. Okay, but after that what we did was just type in y equals tangent of x so we could see what the full graph looks like. And if I zoom in here, you can see that it's going right through my dots. So you can see if I were to be more precise with my angle measures, if I were to find the tangent of all of these values in between, it would create this curve. You might also want to change where the wrench is. Click on that for the settings, and you can change the step value to pi over 2. That would maybe be a good thing to break this up into. Okay, so then you can see the clear asymptotes here. Okay, so it's undefined at pi halves and 3 pi halves. So what we get here are called asymptotes. If I type in the line x equals pi divided by 2, I can see that line right there. Maybe I want to even do it dotted because that's how you would want to draw it on your paper, okay? So those are called asymptotes. Remember, like we had with logarithmic functions, the graph gets really close to them. Even as I zoom out, you can see it looks like it's touching it, but really, even if I go all the way up to these bigger numbers and zoom in, you'll see there is still a space there. Okay, so it gets really close to the asymptote, but it does not touch it. You can also see that this pattern repeats on and on, right? And the period here, so the section that's being repeated has a width of pi, right? So between pi halves and x equals 3 pi halves, this would be our next asymptote. Okay, so this section is kind of what's repeated, right, between the black and the red lines. So the width of this is just pi, so we say that the period of tangent is pi. Okay, it's different than cosine and sine, for example, which have a period of 2 pi. Alright, so after looking at this, students were to sketch this in their notes. Okay, so if we were going, say, from negative 3 pi halves to 5 pi halves, I would want to make asymptotes at all of these, at the pi halves, right, every pi spaces. So not at 0, pi, and 2 pi, right? Tangent has nice values there, right? It's just equal to 0. But at the other ones, the pi halves, it is undefined. So we want to draw our asymptotes there. And then just look at the key points, just like we did for cosine and sine. So I'm just going to focus on where tangent is equal to 0, 1, or negative 1. So in this first interval here, I know that at 0, tangent is equal to 0, so I put a point there. And then at pi fourths, which would be right in between these two, right in between 0 and pi halves, tangent's equal to 1, so my next point is there. And in this next interval, my next nice value for tangent is at 3 pi over 4, okay, right in between these two. And that's negative 1. Then at pi, it's 0. And at 5 pi over 4, it's positive 1. So it looks like these just want to go kind of in a straight line, but we have to remember those asymptotes don't let the graph touch it, so it gives it this curve, right? So we kind of, for tangent, I like to remember that you're always going uphill. So you're kind of going up a hill here, up to pi, and then you turn, but you're still going uphill. So it becomes a steep hill this way. And remember, on both sides here and here, you're getting close to the asymptote but not touching it. So this would be a pretty good sketch just to get an approximate idea of what tangent looks like for between pi halves and 3 pi halves. And it's just repeated in the other intervals. So same thing here between negative pi halves and pi, and then on the other side as well, okay, and over here too. Okay, so it's just repeated over and over again. Just make sure one of the important things here is that I don't have an asymptote at 0. So if I'm just graphing from 0 to 2 pi, for example, I get this upper half Alright, sorry if this part is in the video twice. I paused my recording at some point, so I just want to make sure this is in there. Again, if you're graphing from negative 3 pi halves, say to 5 pi halves, I would start by drawing my asymptotes, and then I'm graphing these significant points. So in here, I know tangent of 0 is 0, tangent of pi fourths is 1, then tangent of 3 pi fourths, right in between pi halves and pi, is going to be negative 1. Tangent of pi is 0, and tangent of 5 pi fourths is 1. Okay, so it keeps that kind of diagonal line look to it, but that's just our significant points. Remember, the actual graph has a curve to it and can't pass the asymptotes, right? So the graph here should look like this. It goes uphill for the first half, and then it kind of turns. It goes up like a steeper hill in the second half. And at both ends, it's getting close to the asymptote, but still not touching or crossing. Okay, and then the same pattern continues in each of these intervals. Okay. Okay, after going over our graphs, we discussed these questions. So again, what's the period for tangent x? Remember, that's going to be like the width where it repeats, and that happens every pi. So this goes from negative pi halves to pi halves, for example. The distance here then is pi, so the period for tangent is pi. And then this is different from sine and cosine, which both have a period of 2 pi, right? Sine looks like this, from 0 to 2 pi, and cosine looks like this, from 0 to 2 pi. Okay, and then repeats. What angle measures is tangent equal to 1? That happens at pi fourths and in between there. Okay, so yeah, pi fourths or 5 pi fourths, it's equal to 1. And then that repeats again once you go into another interval or another like period of the function. So it'd be 1 here, and then this part is 1 here, and 1 here, and so on. Okay, tangent x is equal to 0, anything that has just a straight pi. So 0, pi, 2 pi, 3 pi, 4 pi, 5 pi, and so on and so on. Those are the values where tangent's equal to 0. And then where is it undefined? Remember, that's anywhere where we would be dividing by 0. So that happens at pi halves, 3 pi halves, and then any other times we go around the circle. So it could be negative pi halves. Sorry, I wrote that wrong. 3 pi halves. So if we go around the circle again, we would be at 5 pi over 2, then 7 pi over 2, and so on. Or we could also have negative angles, so negative pi over 2, negative 3 pi over 2, and so on. Alright, and that is it for today's lesson. So thank you guys, and work on your homework, and I'll see you tomorrow. Thanks.